This is a quick introduction for fAIr to show how creating a model using a small training data set can be generalized for bigger imagery for this from the same nature. It might be like in theory what we're talking about. Let's show that in a practice. This is a training data set that we can create on fAIr. It's training data set here. And the training data set will consist of an imagery, which is coming from Open Aerial Map. This is the whole imagery coming from Open Aerial Map. And we define a small area of interest. Currently, this small area of interest is around 15 to 20% of the whole imagery. And what we can do is we can map this manually inside OSM and grab those labels back. We can also go to OSM using ID editor and fix any labels that is not aligned, and then we can come back to fAIR and do this click to fetch the data from OSM and make sure the training data set is accurate. Now, after creating this training data set, we went to create a model, and this is a different page from the training data set list. This is a list of models, Kakuma building model, and here we can submit a training for the same imagery for the same data set and using different zooms and using epoch and patches. We can think of epoch as and patches as the number of times the learning algorithm is going through the entire training data set. Those are the epochs, meaning when we see, say, 20, we will be creating this training data set and then we will feed the training data set 20 times into the model. And for each time, we will be checking the accuracy of the model and record that. The patch size is the number of pairs that will be fed to the model in each round, meaning 8 pairs, meaning each label and a chip, which is the tile in this case, will be fed into the model until the training data set is finished. So we have currently a training data set of 252 images. We will take 8 images each time until we finish the 252. And then we will repeat this process 20 times. And we will use all zoom levels. Now, we trained this model earlier and it took less than an hour. Then we published this training and the model is ready to be used for inference. Remember, we trained the model on an area here, so we will use the inference. This is the inference page. We will try to use the inference in a different location. Currently, since we're using the minimal specs, the response time is around between 10 and 15 seconds for each inference. Those are data produced live from the model based on the training we've got recently. We can try it in a different place, in different zoom levels. We won't get always the same results from inference because that would depend on the imagery we're using and the different tiles we're taking as an input to the model. But in each time, it will work the same. We can have some enhancements regarding the area and the tolerance, and then the same as the Q function we use in JSON or ID editor. This is the current scenario, and thank you.